Okay, physical science students, today we are going to move on in our discussion of work, power, and simple machines by beginning to discuss machines. And a machine, you probably think of machines as like construction equipment or cranes or dump trucks or I don't know, there are lots of different ones. But scientifically, our definition of machine is a device that changes the force or increases the motion when you're doing work. And we are going to focus mainly on simple machines, and these are machines that do work with only one movement of the machine. And some of these are things that you may not think of as being machines. A compound machine is when you take more than one of these machines and you put them together to do a task. All right, so what do machines do? Machines increase speed, they change the direction of force, or they increase the amount of force that you put in. There are 6 simple machines. We have the lever, the wheel and axle, pulleys, inclined planes, wedges, and screws. And wedges and screws are really just versions of the inclined plane. All right, so we judge how well a machine or how much a machine helps us by 2 different quantities. The first one is mechanical advantage, and this is the ratio of the output force to the input force. How hard you have to push, that's the input force, compared to how hard the machine pushes. All right, and again, you might be thinking here, what are we talking about? Machines pushing and you pushing. So again, input force is what you exert, output force is what the machine exerts. And the equation for this thing called mechanical advantage, MA, is the force out divided by the force in. Wait for this to clear. And there are no units. This is just a ratio. So force out is measured in newtons, force in is measured in newtons. Newton divided by Newton is 1, so the units cancel out. So for example, I could have a mechanical advantage of 5, or I could have a mechanical advantage of 0.5 or 1, or any number you think of, but there won't be any units. If the mechanical advantage is 1 or more, if it's more than 1, then that machine is pushing harder than you are. If the mechanical advantage is less than 1, then you're pushing harder than the machine is. All right, so here, calculate the mechanical advantage of a hammer if the input force is 125 newtons and the output force is 2,000 newtons. So in this case, it would be 2,000 divided by 125. You strike the hammer, or you move the hammer with a force of 125 newtons. The hammer will do 2,000 or push with 2,000 newtons of force. All right, so it's pushing 8 times as hard as you are. 16 times as hard as you are. So the mechanical advantage would be 16. So again, what do different mechanical advantages mean? If you have a mechanical advantage of less than 1, you have to apply more force than the machine. If you have a mechanical advantage equal to 1, you supply the same amount of force. And if you have a mechanical advantage greater than 1, you supply less force than the machine does. These feel really easy to use. These are like teeter-totters that are perfectly balanced. And these are things like screen doors, or actually all the muscles and joints in your body. You actually have to push harder to lift things, which it seems odd. All right, so then we get to something called efficiency. This is another way of figuring out how good our machine is. Efficiency is the ratio of output work to input work. So like we said, when you use a machine, you're doing it because you want to make work easier. But the thing that you're not doing is you are not doing less work. You're doing more work. In fact, you're doing more work than you would do if you didn't use a machine. However, it's easier because you're maybe using less force. So for example, look at this lever here. I've got a weight right there. This is where I'm going to push down. Now, I might not be able to lift this up, but if I only have to push down with a little bit of force here to lift that up, I will have to move it through a greater distance. And I've got a couple of videos that we're going to watch so that you can kind of see how that works. But the output work, the lifting of this will be less than what I actually do. I'm going to have to not only overcome the amount of work it will take to lift this, but I'm also going to have to overcome the friction that exists at the fulcrum here. So I have to do more work all the time than it actually requires to lift that object. But that doesn't mean it's not easier. So we can decrease how much output work we're going to do by reducing the amount of friction that exists within a machine, but we will never get it to be less than 100%. So to figure out the efficiency of a machine, we take the output work, we divide it by the input work, and then we multiply that by 100%. And efficiency is expressed as a percentage. So for example here, let me go back. Okay, find the efficiency of a machine that does 750 joules of work. So again, efficiency is efficiency equals work out divided by work in times 100%. Okay, that means that will equal 750 joules of work out divided by the input work of 1800 joules times 100%. And so I don't know what 750 divided by 180 is off the top of my head, so let's just open up a calculator here. We go 750 divided by 1800, and that's 0.416, we'll say 0.42 times 100%, which equals 42%. So what is this saying? That the machine has an efficiency of 42%. What it means is that 42% of the work I'm doing is actually going to lifting the load. 58% is just used to overcome friction. So that is not an uncommon efficiency that you get for some machines. Cars are notoriously inefficient devices. You know, we're talking less than 30% probably. So when you're burning gas, most of that fuel that you're burning and using in a car is not going toward moving the car forward, it's just toward overcoming the friction. So, you know, car engineers keep trying to find more and more efficient ways to create the moving parts in the car so that they become more efficient and consume less gas. Okay, so that is it for today.